All right, today we are going to be talking about how to do division with complex numbers. This is our last lesson in this unit, so everybody get excited. All right, to start off, we want to review the process of rationalizing a denominator. We talked about this in Algebra 1, but we need to revisit it because it's going to be a big part of our lesson today. So when we are dividing by a square root, remember we can't have a square root be in the bottom part of our fraction, so we need to get rid of that square root. The easiest way to get rid of a square root or to rationalize a denominator, is to multiply both top and bottom by the denominator. So in this case, we're going to multiply both top and bottom by that square root of 6. So 10 times the square root of 30 times the square root of 6. So when we do that, that becomes 10 times 30 times 6. So that would be 180. 10 times the square root of 180. And on the bottom, I've got 2 times 6 times 6 is 36. And square root of 180. We can simplify that. Let's see, I know 180, let's see, it is not divisible by 100, and it's not divisible by 81. Let's try 64. Nope. 180 divided by 49. Nope. 180 divided by 36. There it is. 180 is divisible by 36. So that becomes 10 times 10 times 6, because the square root of 36 is 6, times the square root of 5. And on the bottom, we have 2 times the square root of 36, which is 6. All right, so now we can simplify that. Those 6's just cancel out. And 10 is divisible by 2. Because that becomes 5. So our final answer is 5 square root of 5. All right. So expressions in simplest form cannot have square roots in the denominator. So, for example, 2 here, we need to multiply both top and bottom by the square root of 5. And that gives us 20 square root of 5 over the square root of 5 times 5, which is 25, which is 20 square root 5 over 5. And 5 and 20, actually, 5 goes into 20 4 times. So our final answer is 4 square root 5. And that is our final answer, and as simple as it can get. Now, remember, the imaginary unit I represents a square root. I is the square root of -1. So because of that fact, anytime we have an I in the denominator of a fraction, it contains an imaginary unit. And we have to rationalize it. So to do this, we need to multiply the numerator and the denominator by the complex conjugate of the denominator. Now, a complex conjugate, it sounds big and scary. It's not. It's very simple. The complex conjugate of a complex number, a plus bi, is just a minus bi. So in other words, all you have to do to find the complex conjugate is change a plus sign to a minus sign. It really is that simple. So the complex conjugate of 2 plus 3i is 2 minus 3i. That's all there is to it. The complex conjugate of -3 minus 3i is -3 plus 3i. It's really that simple. C is probably the most confusing because it's just a 2i, but remember that's the same thing as 0 plus 2i. So we could rewrite this as 0 minus 2i, which is just -2i. All right, so that is how we get a complex conjugate. Now, when we are going to simplify this, we are going to multiply by the complex conjugate of the denominator. We always look at the bottom number. That's what tells us our complex conjugate. We don't care about the top number. It's just kind of along for the ride. All right, so we're just looking at the bottom number. In this case, we're looking at the 5i. Now, we're going to multiply by the complex conjugate. The complex conjugate of 5i is negative 5i. So we're going to multiply by negative 5i. But we're not just going to multiply the top or the bottom by negative 5i. We have to do the both. Because what is essentially happening when I multiply both the top and the bottom by the same thing, remember, anything divided by itself is 1. Essentially what I'm doing is I am multiplying by 1. I am not changing the value. I'm just changing the way it is represented. Okay? So, when I multiply by this complex conjugate, I'm going to distribute this negative 5i to everything on top. So negative 5i times 3, that's negative 15i. Negative 5i times positive 10i, that's negative 50i squared. And on the bottom, the 5i times the negative 5i is negative 25i squared. All right, so now we are ready to simplify. Remember that I squared is the same thing as negative 1. So negative 50 times negative 1 is positive 50, and we always write the real part first, minus the 15i over, remember, negative 25 times I squared is the same thing as negative 25 times negative 1, so that's positive 25. Now, we can simplify that a little bit. Obviously, 50 divided by, so really what this is, like 50 over 25 minus 15 over 25i. And we can simplify that to 50 divided by 25 is 2. And negative 15 over 25, that can all those can be divided by 5, so that's negative 3/5 I. And that is our final answer. 2 minus 3/5 I. All right. So that is how to divide by just an imaginary number. So what we're really headed towards is simplifying by multiplying by complex conjugates whenever they're complex numbers that are in the denominator. So we're going to be multiplying now by the complex conjugate of 4 plus 2i. And of course that is 4 minus 2i. And whenever I multiply on the bottom, I multiply on the top. So now we are going to distribute the 2 and the 8i to the 4 and the negative 2i. So that means it's going to be everything in the first parentheses times everything in the second parentheses. And we got to do that for both top and bottom. So 2 times 4 is 8. 2 times negative 2i is negative 4i. 8i times 4 is 32i. And 8i times negative 2i is negative 16i squared. Now on the bottom, we have 4 times 4, that's 16. We have 4 times negative 2i, so that's negative 8i. We have 2i times 4, so that's positive 8i. And then we have 2i times negative 2i, so that's negative 4i squared. All right, now we want to simplify that, clean it up. 8 can stay the same. Negative 4i plus 32i is 28i. And then the negative 16 times I squared is the same thing as plus 16. Then on the bottom, those are going to cancel out. Negative 4 times I squared is like plus 4. So we can combine our like terms on top. 8 plus 16 is 24. On the bottom, we have 20. Now, our last step is we want to write this in a plus bi form. So that means we're going to separate this into 24 over 20 plus 28 over 20i. Now we can simplify that. 24 and 20 are both divisible by 4, so that becomes 6/5 plus. And then again, 28 and 20 are both divisible by 4, 7/5 I. And that's our final answer. 6/5 plus 7/5 I. All right. So that's in the A plus BI form that we need it to be in with the simplest form. All right, so we're going to do this again. 4 plus I over 2 minus I. So we're going to multiply both top and bottom by the complex conjugate of 2 minus I. And that is 2 plus I. Okay, so again, we're going to distribute everything in that first top part to everything in the second. So 4 times 2 is 8. 4 times I is 4I. I times 2 is 2I. And I times I is I squared. And then on the bottom, 2 times 2 is 4. 2 times I is 2I. 2 times, our negative I times 2 is negative 2I. And then we have negative I times I, so that's negative I squared. So we need to simplify and clean that up. We got 8 plus 6I, I squared is negative 1, over 4, the 2I and the negative 2I cancel. Negative I squared is going to be positive 1. So 8 minus I is 7, plus 6I over 5. Now again, we need to write this in A plus BI form. So 7/5 plus 6/5 I. And that's our final answer for that division problem. Now, the same concept holds true for radicals in the denominator. Instead of the complex conjugate, we're just going to use what we call the conjugate. Okay, so the same idea applies. We cannot have square roots in the denominator. So we're going to multiply this 5 plus the square root of 2 over 2 minus the square root of 3 by the conjugate of 2 minus the square root of 3, which is, again, all we're doing is changing from minus to plus. So 2 plus the square root of 3 over 2 plus the square root of 3. And again, we are going to distribute everything from the first fraction with everything in the second. So 5 times 2 is 10. 5 times the square root of 3 is 5 square root 3. Square root of 2 times 2 is 2 square root of 2. And the square root of 2 times the square root of 3 is the square root of 6. All of that over 2 times 2 is 4. 2 times the square root of 3 is 2 square root of 3. The negative square root of 3 times 2 is negative 2 square root 3. And then negative square root of 3 times the square root of 3 is negative square root of 9. So now we are ready to simplify. Well, the top part, there's nothing I can do to simplify that. I could write it in ascending order of the square roots, so 10 plus 5 square root 3 plus 2 square root 2 plus the square root of 6 is really about as simple as I can get it. If I wanted to, I could just change the order around of these middle two to kind of clean it up a little, I guess. 2 square root 2 and 5 square root 3. And that's really all I can do. On the bottom, though, there's lots I can do, right? Those cancel out. And the square root of 3, our square root of 9 is 3, so this is 4 minus 3. So that's over 1. So this is just our final answer. 10 plus 2 square root of 2 plus 5 square root 3 plus the square root of 6. And that's as simple as it gets. I cannot simplify that any further. All right. So remember, that is how you rationalize the denominator with radicals in them. That'll pop up again later on. That will not be in the homework for today, but you'll see that again throughout this semester and throughout the school year. So make sure you remember how to do that. We'll do it again later. All right, have a good day, and if you have any questions, please shoot me a message on Canvas or an email. I'll get back to you as soon as I can.